Here we go, everyone. Severe thunderstorms about to make their way into northwest Arkansas. You saw some of the lightning that is off in the distance. Rogers, Arkansas is going to be impacted. Now, I will show you that this line that's moving in is weakening on the south end. And the reason for that is the outflow boundary. We got a lot to talk about. We'll continue to keep you updated, but could be a busy night as the line that's west of the initial line of storms is pretty impressive. So let's check it out here as we look, first of all, at Heil Heating and Cooling Mega Doppler. Like I said, it's just me, myself, and I right now. We've got Blaze Thomas, who's in the hotel room. I know I'm tired too. I understand you. And it's just like, oh, man, I'm so tired I could fall asleep myself. River Valley is going to be impacted as well, Rick. And you know it's warm, it's humid. We'll show you those temperatures. But let's take a look at Heil Heating and Cooling Mega Doppler. And because it's just me, myself, and I, we're going to be able to move around here. Notice I've got the lightning tie on. As of now, not looking at tornado potential for us, but look off to the west. This is a really intense line of storms with multiple tornado warnings. In fact, you got 4 tornado warnings that are currently in effect for the Oklahoma area. Now, this cluster of storms right here that's moving into northern Delaware County, that's severe thunderstorm warned, by the way, for another until 11 o'clock. So severe thunderstorm warning just for a couple more minutes. And then you got a severe thunderstorm warning that's been issued for 31 more minutes, and that's going to go until 11:30. That's on the north end of the line. This is going to dissipate, and you can see this outflow boundary. That outflow boundary, by the way, is quite a ways ahead of the storm system. And so what that does is that creates basically, let's just say, weaker storms because you have cold outflow that's not fueling the updrafts anymore, and so those are dissipating. Now, the problem is that this could be literally an outflow boundary that gets laid over the area and gets draped over the area, and as this line of storms comes in, that could get pretty intense. Now, will that continue to hold together moving into northwest Arkansas? I do think that's a possibility, and I think that's not out of the question to see that. So we'll be watching that closely. But let's track this out. Let's show you some of the ingredients that are in place. And so one of the things I want to show you is with GR Earth. So GR Earth, we're looking at, first of all, several things. 850 millibar winds. See how they're increasing in speed? So you got 25 knots at 850. We're going to take that off the screen. Notice the new tornado warning that just got issued. That is for north central Oklahoma and central Oklahoma, anywhere along this line. Now, what we're looking at here is a significant tornado parameter. And I'm going to take our camera off the screen. But this is Heil Heating Cooling Mega Doppler on, let's just say, steroids, legal steroids. How about that? Performance enhancing drugs, which are legal for in the weather department. Anyways, here's a look at all the storms, and you can see that significant tornado potential is greater farther west. Now, over time, that's going to start moving eastward. As you'll see here when we loop this, you'll be able to see that moving east. This, by the way, is the different risks that are in place. You got the local storm reports. And what is that outline? Let's go look real quick. There's a super large ring. I want to see what that was. So anyways, as that loops, I'm pausing that real quick. I want to see what that is. That's the mesoscale walk. So mesoscale discussion, that's what that is. That makes sense. So if we go along in time, you can see how that instability is on the increase. Surface-based CAPE, still pretty impressive. Maybe not quite as much in northwest Arkansas, so the storms could be weakening. It's not out of the question that they do. Surface-based SIN is definitely there, but not enough where the storms aren't tornadoing, or at least tornado warnings in Oklahoma. And we go down the line. Supercell composite, definitely a lot higher along the leading edge of that line. We look at the 0 to 1 kilometer storm relative helicity, definitely greater farther west near the line. The effective storm relative helicity, you can see that that's also greater. So everything is greater out to the west. That's why we've got these thunderstorms that are pretty intense off to the west. We'll take off the mesophil. You can see those temperatures are currently in the mid 70s. If we go back and look at the dew point, you'll see we're at 74 for the dew point in Siloam Springs, 70 for the dew point in Bentonville. So a lot going on there, but this cluster of storms is starting to die out a little bit. It did have 65 miles per hour winds off to the west. So this line still has to come through, and it's definitely something that we will watch. Now, how does that evolve over time? Well, the models aren't perfect at this. There is a severe thunderstorm watch in effect. And remember that low level instability might be on the increase as it makes its way into our weather coverage area. So there's the tie. This is the big lightning tie, by the way. Not essentially for the cluster that's coming in. That's going to be not really a big deal as it clips southwest Missouri. That's really honestly starting to weaken. But there is a look at the severe thunderstorm watch that's in effect, along with the flood watch that's over the same area. Now, that severe thunderstorm watch officially goes until 4 a.m. for Benton and Washington County. I do think that 4 a.m. might be a little long, but then again, that other line making its way eastward will be something to watch. So it's definitely an intense line. Will it hold together? Time will tell. But here's a look at that line, and here's a look at the storms. Now, what we can do is we go farther west. I don't think I have the Oklahoma City radar, but look at that. That is a pretty intense line that's moving eastward. And so right now, everything is farther west. But over time, let's see how that evolves. However, if you are wondering what to do as severe storms will be moving in soon, and you're new to this area and you don't know exactly what to do in severe thunderstorms, and you don't exactly know where you're at with severe thunderstorms or what county you're located in or what location you are within the county, I've got the solution for you. This is Weather Call Next Gen. Now, if you have someone that's watching this live stream with you, all you have to do is scan that QR code. That QR code right there will be able to show you what's going on with warnings. It will call you. It will let you know. Now, if you know about Weather Call Next Gen, you've got it. But calls, texts, and emails to subscribers only within that storm polygon. So, for instance, Northern Delaware County, you got a call saying severe thunderstorm warning. Tornado confirmation calls, immediate phone alerts for observed tornadoes and warning upgrades. Extreme severe thunderstorm alerts. These are all things that can happen that you don't even know takes place if you are, in fact, let's just say, not real keen on severe weather. Golf ball size hail, wind driven golf ball size hail. We had that. Remember May 18th. May 18th brought, let's just say, a lot of storms and hail across the Bentonville or across the Springdale, Tawnytown area. And the last but not least, rural locations with poor cell service, calls to landline phones. So scan that QR code, or you could go to that website, weathercallservices.com/KNWA-next gen. So that will give you alerts. It's about $12 a year, so $1 a month. If you want the lightning data, that'll cost a little bit extra. Let's talk about the tornado risk. Emily's asking about it. Let's get into it as we look at the severe weather potential. So right now, we kind of looked at the ingredients. You saw that it was greater off to the west, and there's going to be more energy off to the west. But let's take a look here at, first of all, that cluster of storms that's moving in. Clearly, you can tell it's weakening, but this line is not weakening. And in fact, it's pretty intense, and that's going to make a run for Northwest Arkansas. And that's the question. Do you expect it to weaken? I expect it to weaken a little bit, Taylor, but not entirely. So something where we definitely have to keep our guard up. And here's the reason why. Look at this cluster of storms. It's got a lot of fuel to work with in Northwest Arkansas. That fuel really honestly isn't going anywhere. And if we put this into motion over the last hour, you can see those storms, even with tornado warnings, are kind of out of that highest air gradient, essentially, for instability. So let's go to the risk. Let's show you the risk. The risk is greater farther west. That's understandably so, because that's where the greatest energy, the greatest lift, all that stuff is. And you see that when we zip in, there is the severe thunderstorm threat. We're talking after midnight for that cluster of storms moving in, even a little before midnight if it holds together. If we check out the individual threats, here is the tornado threat. So if you're wondering, yes, it's not super great, but it does include Northwest Arkansas. Now we actually have, I'm going to share this here. We've got a photograph right there that shows that critical angle isn't too shabby. Now, what is your storm motion on that? Looks like that might be a little quick. What do we got for a storm motion? I'm thinking, let's see here. 282 at 48. 48 knots is how fast those storms are moving. But that's a lot of shear. And that critical angle is, let me bring that up full here so I can see real fast. 98.2, so a little over 90 degrees. If those storms move a little more easterly, that could be game on. So we'll be watching that closely. That's a photograph, by the way, which my weather intern as well as Blaze knows how to read now. So we were kind of running through some of that. Blaze might be jumping on here soon. So that's a lot of money right there. $1,700 a month. That's right. I will text you personally for that. Man, if I can come up with something that's $1,700 a month. You know, honestly, that's about the price of Numa. If you know about Numa, it's a exercise program that my wife and daughter are into, and no knock to them. They know what they're doing, but their monthly rates they're pricey. And my wife says it's well worth it, though. It's an incredible workout. So, anyways, let's go back to the real deal here as we look at that tornado risk. So, we've had a lot of tornado warnings. We haven't seen as many confirmed tornadoes, but there's a look at the tornado risk, which is about the same for far northern Northwest Arkansas. Let's see here. No, that's the right link. Let me send it again here. Stand by. Okay. Yeah, maybe it was the wrong link. Just popped up. So, yeah, I know. I understand. It'll take a little bit of time to understand, but there's the damaging wind potential. That's what we really have to watch as this line comes through. And over 75 miles per hour is going to be possible. Here's a look at the future radar. Okay, so this line kind of falls apart as it shows, but there's that line coming into Tulsa around 1:30. And I think that's kind of on the money because if you look, this is what Mega Doppler has, is that line is west of Tulsa, and it has it coming in around 1:30. So honestly, I don't think that this computer model is too bad showing that line of storms. Then at 2 a.m., that line is still pretty impressive. And yes, there is going to be some minor hail with this. Hail could be the size of ping pongs, honestly. Then that kind of moves eastward, and it does start falling apart, but not entirely. So 2 to 3 a.m., we'll take a look at helicity tracks. That's a good question. And then you could see that storm system kind of falling apart, but additional rain continues across the area throughout the day tomorrow. So a lot of energy moving in. We'll look at the water vapor here in just a bit. Well, let's check out helicity tracks because that is a good question. Now, I bet you they're not going to be super great. And the reason I say that is because typically with QLCS tornadoes, they don't work as well with QLCS tornadoes as it does with supercell tornadoes. Well, let's check this out. So here's your helicity tracks. Yeah, see, it's got some around 3 a.m. coming through. And that was enough to prompt tornado warnings. That was kind of like what we had on June 7th and June 6th. And then you could see that falling apart. And then more helicity tracks. But if you'll notice here, a little stronger off to the west. So there's your maximum updraft helicity tracks. We'll look at this one here. And looks like we got Blaze joining us. So we're going to add him here soon. Live from the Best Western. There's a look at your helicity tracks coming into Northwest Arkansas around 2 a.m. So, yeah, going to get a little active. Ooh, before Blaze, we bring you up. You know what? Actually, I change my mind. We're going to pull an audible, and we're going to bring you up here with the hodograph. Blaze, I'm going to unmute your mic. Let's go.
Okay.
All right. So now, here's the deal. That looks like an impressive hodograph, doesn't it?
It does, yes.
All right. So, live quiz time.
Oh, no.
Yeah. You got this, man. You got this. Now, he just learned how to read hodographs not too long ago. We're going to bring this up full. Fire away. First of all, what are we seeing with that big dot that you see just to the left of center?
We can see that that's pretty strong critical angle.
Yeah. Now, strong critical angle. That's right. It's nearly 90 degrees. However, what does that dot represent?
It's where the initial storm is.
Yep. Now look, you can see the black dot, and you can see the legend up at the top right. What does that say? Surface wind.
So that's where we're going. We start at the surface and then we go up.
Yep. Go up in the atmosphere. All right. So now here's the question. What type of wind is that? If that's the surface wind. You got this, man.
That is going to be 10 knots.
Okay. 10 knots in what direction?
It's going to be to the exact
what direction?
It's flipped. So
remember, it's coming from. What direction is it coming from?
It's coming from the west.
No.
No.
It's coming from the east northeast. That's an east northeast wind. Because that line on the left-hand side is 90 degrees. Remember? You
Right.
flip it around on the hodograph. In fact, you can kind of see S is up at the top, so south wind. It takes a while to learn this. So we'll continue to adjust. But what's the 0.5? What's the half-kilometer wind?
The 0.5, that is going to be about 30 knots to the south.
Well, it looks like it's 20 because you can see the 10 rings. So you got the 10 knots, and then you got the other ring that's 20 knots.
Yeah, you're right.
Yep, yeah. It might be a little small to see, but so you got this one. Backing or veering profile?
It's veering.
Yes, veering profile, which is a warm air advection profile. Regardless, that's a pretty impressive critical angle for Fort Smith and the surface wind at KTUL, which is Tulsa Airport. And that's where you could have that tornado potential. So that's something to watch for sure. And that is a hodograph. So good job, Blaze. Well done, sir. I know it's tough, and that's maybe a different hodograph from what you're used to seeing. But and it's late too, as well. You've been working all day.
It's that flip. It's the flip. How the direction just flips. That just throws me off every time.
I know it does, exactly. And then the storm motion is a little bit different. But the reason that it's flipped is because in a severe weather environment, you typically have a strong south wind. So let's look at the winds. Let's look at those surface winds. Let's get back to these graphics here, and we'll take a look at our surface winds, and we'll show you as we get back to the weather. So let's look at the southerly winds, and then we're going to check out the radar, and then we're going to look at the future radar. There's just a lot going on here. So surface winds with wind streams. So it shows calm right now, but the Tulsa wind, it almost shows that the boundary is moving more westerly. But look at those east northeast winds that you kind of see briefly. So it's not perfect. This is just the model representation, but you can kind of see some of the boundaries. So let's look at the actual winds. If we look at regional, what kind of wind do we have in current winds? And I got a different wind too, a wide DMA wind. But regardless, you can kind of see those little bit of easterly winds. So they're saying the winds are picking up over northwest Arkansas. Let's see. Maximum wind gust 39. Whoa, look at Wichita. Holy smokes.
Wow.
101 miles per hour. That's a pretty impressive line. So if we look at the winds locally right now, they're starting to pick up a little more out of the south. So that's something definitely to watch. I know. Blaze, I would say I did you dirty, didn't I?
No. I just
Yes.
I'm learning. It's a learning process.
It is. Absolutely. Well, here's what we're doing. We've been watching this, and I've been learning about GR Earth too, and you've been telling me about that. So take us through that as we check out GR Earth and what we've got cooking there.
Well, you'll have to can you full screen it?
Don't worry about that. Yes, sir. All right. So first of all, we're going to bring up. So this is GR Earth right here. And here we've got the line. Now you can't do velocity with GR Earth, can you?
No, you can't. That's
The reason for that is because you got a composite radar image. So you go across the country, composite radar image. But this line is dying, by the way. There's a little bit of lightning, but just not much. So we don't really have to worry about this as much. Severe thunderstorm warning for 10 more minutes.
yeah. I noticed that they were adding special weather statements instead of a warning for that.
Look at this right here.
That's some strong instability.
Strong instability. Yep. And then what are we looking at here when we look at the effective storm relative helicity?
That would be the wind shear.
Yep.
That's pretty strong.
We look at surface-based sin. Look at how strong the sin is. A lot of sin. So that could be something that weakens this line. That's not out of the question if it weakens the line or not. And then we can look at effective storm relative helicity. We can look at the 0 to 1 kilometer. Now, one of the things is that we don't have quite the wind shear over our area for these storms to maintain themselves as much. So hopefully this line weakens and it dies out. It's all moving eastward. You can tell the way that it's moving by looking at the line. So let's flip back to regular mode, GR, not the GR analyst. There you see the line moving eastward. There's all the tornado warnings, and then they just got dropped briefly. And now we've got this. Look at this bow echo developing right here.
Yeah, it's really. I was just noticing that. That's bowing. Ooh, that's some strong winds.
There, 70, 80 miles per hour right here. This might become a considerable severe thunderstorm warning. I noticed that Tulsa's doing some weird stuff with their radar tonight. I don't know. The Tulsa radar is acting kind of strange. I don't think we get an outbreak tonight. I really don't. think we see some severe weather. There's a severe thunderstorm watch, but I don't think we get an outbreak. So we'll take a look at this here and we'll pop that up. I'm noticing some comments on the stream. Yeah, we're going to pop that off real quick. It's kind of cool that you can pop those up in real time, but I mean, it's not a bust yet. No, it's coming in here pretty soon, just to let you know. So, what time is it moving in? Well, Blaze, what do you think, man?
I'm thinking probably right around 1 a.m. ish, 1, 2 a.m.
Yeah, let's see here.
Because I know with the initial or that first storm we were looking at, but has now fallen apart, that one was going to impact us right around, 11:30 midnight. And so now, yeah, it's probably 2, 3 in the morning.
Yeah, I think so. So we've got it covered. Josh Rugger is going to be on it. That cluster of storms is dying out to the west and northwest of us. Still some occasional lightning, but man, that thing is really weakening. But we still have the other line to go through. We still have a lot of instability, and we are under a severe thunderstorm watch that goes until 4 a.m. So we still have a little bit of stuff to go through. Let's talk a little bit about some other things that are going on, including the heat risk. So you're good to sleep for now because that cluster of storms is starting to die out. Let's give you the 7-day forecast real fast. Notice that we do have that severe potential and rain. Rain is looking pretty likely tomorrow morning. I'm hoping it weakens. It's definitely possible. 85 for tomorrow for the high, and that might be a struggle to get to just because of all the cloud cover and rain. Yeah, we do have heavy rain potential. And then Thursday, some light rain in the morning. We're talking early morning. And then there's summer, starts at 9:41 p.m. Central Daylight Time. Saturday and Sunday in the lower 90s. And then as we go into Monday and Tuesday, we're in the lower 90s as well. So some heat and humidity coming our way. It is going to be a scorcher. Thursday in the lower 90s, Friday in the mid 90s, and then Saturday and Sunday in the mid 90s. So we've got some heat and humidity coming our way. You can come on in. Yeah, no problem. Lower 70s. You know it's late when you're here in the cleaning crew. The cleaning crew is still here. So one of the things too is that humidity is just going to be through the roof Saturday and Sunday. OLED TV. Did not get an OLED yet, but I got an OLED monitor, which, by the way, let's see. Here's the deal about tomorrow's threat. I don't really think we see much on tomorrow's threat. And in fact, I think this is going to be removed, to be honest with you. I think there's going to be a little bit of tomorrow's threat, but I think it's going to die. And I think it's going to be a lot less. So let me show you what we've got for tonight's threat and then tomorrow's threat. Big time difference. So here is tonight's threat going through 7 a.m. And then they just kind of broad brush this day 2 risk and just put it everywhere. Now, I don't know about you, Blaze, but I just think there's going to be a lot of storms in the morning, and it's going to be tough to get that atmosphere re-energized. I think that slight risk is going to shift quite a ways farther south.
Yeah, I agree. I think it's with all the precipitation and storms, it definitely could trash our atmosphere.
That kind of overworks the environment, overworks the atmosphere for sure. So let's give you kind of a little bit of a timing. Here's a look at the timing that we're expecting. Notice how 1 a.m. we're starting to ramp that up. We might need to bump that up even a little bit more. Got a new tornado warning that's east of Oklahoma City, well west of us, but there's that timing. And then notice it does pop up a little bit during the afternoon to 60%. Thursday, though, afternoon is going to be really nice. Look at the model trying to bring a little bit of precipitation. I don't buy that. And then we look at the River Valley forecast, and you see those rain chances ramping up. Yeah, something is going weird with the Tulsa radar. That's a good question here. Is there going to be tornadic activity with this second line? It's possible, but I don't think the ingredients are quite as enhanced as they are for us compared to Oklahoma. In fact, look at this line falling apart. But that's not a surprise because the outflow boundary was racing way out ahead of it. Look at that. That becomes cold pool dominant. Warm, moist air flows up and over cold air, but it doesn't get fueled by the updraft, and therefore it just starts absolutely falling apart. Now, if we look at the velocity image, it's kind of all over the place. Base velocity, too. It's starting to get cleaned up there a little bit. But if we look off to the west, now it's starting to get a little bit better. Here's a look at the winds. We'll take this and we'll go to set the storm motion from the warning. So there's that area of circulation, and then there's another area of circulation. Well, we're not close enough on that radar to look at that line. So yeah, I'll just let you guys answer some questions. Let's see, got another critical angle here too. Let's bring that up. We'll check this out. So Blaze, here we go. Another critical angle.
Oh no, another one.
No, this time I won't quiz you. But that does look pretty impressive. That's like a 90-degree. That's
It does, yeah.
So yeah, we'll be watching that closely. Here's a look at that again. So you can see that's the Tulsa possibility of QLCS tornadoes. That's 89.3. I don't know if that's the newest photograph. That's a
That is really close, though.
And it's headed eastbound. The amp is looking great for Thursday. No problems for the Walmart amp, or Friday for Toby Mac. Toby Mac concert looks cool. It's going to be good. So we'll see what happens. Basically, what you're looking at here, just to let you know, is this is called a hodograph. A hodograph is a representation of the wind speed and direction with height. And unlike north, south, east, west, you got to flip it 180 degrees. So you're looking at that line to the south. That's actually north. And remember, you name the direction the wind is coming from. It's always the direction the wind is coming from, just like it's the direction the storm is coming from. So southerly winds are basically, if you look at that plus that's in the middle, that plus right there represents the different wind directions. So the line that's going straight up from the center is a south wind. The line that goes from the center to the left is the east wind. The line that goes from the center to the right is a west wind. And then the line that goes from the center down to the bottom is a north wind. So you're naming the direction the wind is coming from. And like I said, to describe how to do a hodograph, Blaze, over a live stream is probably, I'd say, a little difficult.
I would say definitely. I mean, you could definitely tell them, what each ring means in terms of the speed and knots, but it would be pretty tricky.
So those rings are called isotachs, and isotachs are lines of equal wind speed. And that's a pretty impressive critical angle. So why are we looking at that? Because as the storm moves easterly, there's a good chance that there could be some rotation as long as it's not outflow dominant and it's a balanced UDCZ. And that's exactly what we're seeing right now. So if you're just joining on, we've got a pretty intense line of cells that are off to the west, or a pop up the tornado risk here soon. And you're going to see that 2% tornado risk remains over most of northwest Arkansas, except for the 5%, which is clipping northwestern Benton County. So As the storms move in, they will tend to weaken. However, they will still kind of pack a punch. And so we'll see what happens, honestly. It's going to be interesting.
They just issued a new severe thunderstorm warning that goes directly towards Tulsa, 70-mile-per-hour wind gust.
Yeah, and a new one for Southwest Missouri too. So this is just issued here a couple minutes ago. Got a severe thunderstorm warning that goes until 12:15 a.m. Let me look at something here. Oh, I gotta go find a windshield here. Hold on just a second. Ooh, excuse me. So QLCS is known as a quasi-linear convective system. It's not a perfectly solid line. A solid line is more like a squall line. QLCS is like a broken line of cells. So that's why you have that potential for tornadoes in the broken line of cells. But this is that line that we're going to be watching. Yeah, and there's the severe thunderstorm warning. Look at how far out ahead. Blaze, you were mentioning that. That's ways out ahead of the storm. Moving east at 45 miles per hour. So now, at this point, we can start tracking this. Let's do a track. Let's tell you when it moves in and tell you when that storm has the potential to move in northwest Arkansas. Shall we?
Sounds good.
Let's see what we got. Now, Blaze, tell us where you're broadcasting from, because that looks a lot like a hotel room.
You're not wrong. Best Western here in Fayetteville.
Now, what's going on with that? Tell the viewers what's the story behind that.
So I have an apartment, but the lease will not start until July. So until July, I'm in I'm in a hotel.
Well, July will be here before you know it. Is it July 1st?
Yes.
Oh, nice.
Yeah, I'm ready. But I will tell you, the breakfast has been really good. So.
Oh man, I bet. Is that included?
Yeah.
Breakfast included?
Mm-hmm.
Now that's pretty epic when you got breakfast included.
They got eggs, biscuits and gravy.
Oh, so
cereal.
it's a hot breakfast.
Oh yeah, it's delicious.
Let's go. That sounds good. All right. Hey, look at this. Look at this comment right here. You need to host a class because I need my husband to take weather seriously. That's funny. All
I'm
right.
telling you, Dan Scoff is a great teacher.
Well, I appreciate that, Blaze. Let's check out what we've got with the timing of this cell here. So we're going to bring this up full. There's a look at the line. It's moving east at 45 miles per hour. And that's a look at the time that this is coming in. So Fayetteville, 2:41 a.m. Bella Vista, 2:21 a.m. And kind of updating it right there. I'm pushing it a little bit faster. And that bow echo right there could provide some pretty intense winds. That's going to be something to watch. So, are you asking? You can go to bed. Well, here's the deal. It's 11:35 right now. We got a while before this line moves in. The storms that are moving into southwest Missouri are pretty weak. In fact, you can see they're just barely severe. And honestly, probably weakening even more. So that's it right there. And this is a base severe thunderstorm warning that just barely clips northern sections of McDonald County. And there's really nothing else in northwest Arkansas. Now, that's great for this cell, but it's bad for this because that has a lot more fuel and energy to work with. So, what do you think about this? You think Derecho? Derecho? I don't know. Derecho is spelled Dercho. So you were close. Yeah, there it is. Derecho, which means straight ahead in Spanish, by the way. So I don't know if this will be truly a derecho, but we'll have to watch it closely. Could produce a pretty intense line. Tornado potential is going to start winding down if this line becomes more west to east oriented. If it's not, though, that'll be something that we have to watch. So there are some things that we can't show, Blaze, on the GR Earth, by the way. There are some things, including the 0 to 3 kilometer bulk shear. And so in order to show that, I've got to bring that up. So stand by here as we take a look at screen. Go to SPC mesoanalysis. All right. So this is the SPC mesoanalysis. And what you're looking at here is the 0 to 3 kilometer cape, which is important for that low level instability, for the storms to have the spin in the atmosphere at the low levels be pulled up into the vertical. You'll see that we're only at 20, 25 knots, and it's kind of pointed more southwest to northeast. Remember, those wind barbs represent the wind direction the wind is coming from. So it's kind of like a wind vane pointed into the direction of the wind. And if we look at some other parameters here, this is the 0 to 3 kilometer mixed layer cape. So we definitely do have some of that. That does start ramping up as these line of storms come in. So that's something that is concerning. The surface vorticity is definitely on the increase as that line makes its way in. If we look at this is the amount of what we call theta E that's increasing ahead of the line, which means that we have plenty of fuel. However, you'll notice that we're a little weaker on the 0 to 3 kilometer bulk shear, where it's like 35, 40 knots out west. And that's why I think a lot of those tornadoes are happening. And then we got mixed layer cape that shows up. And then finally, this is the one we were wanting to see here, the lapse rates and the 0 to 3 kilometer cape. So we've got the surface-based instability, a lot of sin, though. That's what the models were kind of showing, too. And sometimes you can have that sin, and it weakens the line as it moves in. Here's the surface to 3 kilometer bulk shear. Not quite at 30 knots, which is the threshold for QLCS tornadoes. So, Blaze, that's a whole nother thing we got to talk about. That's going to be a little while.
Becky said, Blaze made me hungry. I guess she's referring to my hotel comment.
Yes, you made me hungry too.
Sorry.
That's all right. No worries. No worries. So if we go back to this line, what area is going to be most likely to produce tornadoes? It's going to be this part of the line. The line that's running northwest to southeast, because remember, that southwest 0 to 3 kilometer bulk shear, it would be right along the leading edge of this line. So this would be the most likely area for tornadoes. But look at this velocity image. It's so weird. Set the storm motion from the warning. You can see a little bit of that rotation. This is where it's going to have that greatest potential. There's something weird going on with the radar. I don't know. Seems like the velocity image is a little off, but man, that is a pretty nasty line of storms with 70 miles per hour winds. But here's the deal. I'm not going to do this live stream for 2.5 hours as the storm is coming through. So I will say this. This is a great question. What is a derecho? Blaze, you know that one yet?
Yeah, it's it has to be 58 mile per hour winds or greater over an area, and I believe is it 240 miles?
Close. 250 miles. And it's miles per hour.
Again, that gets me every time.
Zach still doesn't know, but he would make you do push-ups.
Well,
You're gonna be ripped by the time we got you trained up, ready to go.
that's true. That's true. Well,
Here's
I've made
here's a
several
look.
mistakes tonight, so
Oh yeah, that's right. Here's a look at Derecho. So obviously not storms on Wednesday, although maybe if it is a Derecho, it would be a recap of the storms on Wednesday. So it's a Spanish word meaning straight. It's a thunderstorm complex with damaging winds of 58 miles per hour or greater along the entire span of the front. And it's got to be a thunderstorm complex that goes at least 250 miles in length and must be maintained for 6 hours. So that's pretty impressive. What's wild about that is look, if you look at the area that's most likely to see derechos, what does that look like?
it's literally our area,
Yeah,
Northwest Arkansas.
derechos every 3 years. And look at that one. That puts us kind of right over the bullseye. But our last derecho was quite a while ago, June 12th, 2009. I like this comment right here. Look at this. Girlfriend walked in, turned on TV down, but it's Dan. She looks at the TV. He's not wearing his tornado ties. Turn it down. Sorry, don't mean to upset the girlfriend, but you know what? I might have the tornado tie. Yeah, Iowa got blasted, man. That was a bad derecho. In fact, you're talking about that. We used to have that radar showing up. Um, this won't have the radar on there, but this kind of shows you where the derecho started. So made its way east. So damage reported started eastern Nebraska, and they made their way all the way across. It doesn't show anything. Damage reports end. So it was over 700 miles that storm went across. So obviously that's not going to work because we don't have the radar anymore. But we did make a render of it when we did have the radar, and might be able to show that. So watch this graphic. This is kind of cool. So it shows 58 miles per hour with that storm moving east, and it's got to be a damage path at least 250 miles in length. So there you go. Was that worth having the TV up? I don't know. Looks like we got another Hodo to look at here. There it is. There's the new Hodo. Let's see, add to stage. There we go. Oops, here we go. Let's see if we can bring that up. Oops. Huh. Don't know where that went. There it is. So there's the new Hodo. And critical angle is good, but I think those cells are moving more easterly instead of east-southeast. I know it shows 273, but it seems to me like they're moving more easterly, if anything.
Yeah, I agree with that. Looking when you put
Yeah.
the radar in motion, that's exactly how it looks.
You want to have one more quiz?
Preferably no, but
Okay, we'll pass on the quiz. We'll still train you up. But I will say here, if we look at this, that red dot right there indicates a storm that's coming from the west northwest, moving east southeast at approximately it's about 38 knots. If I had to put a degrees on that, I would say 278 at 38. Which, by the way, look, it's got the legend right up at the top. So that's pretty cool. Let's see if we can catch us some lightning from some of our Weatherbug Network cameras. Always love a good lightning show. And we'll probably see one as this storm gets closer. So I bet you Bella Vista will have something that they can watch. lightning is not super intense, but there's a look at that photograph. Pretty cool.
Do you have chat open right now?
I do.
NWS chat?
Yes, I do. Do you as well?
I do, yeah.
What are you seeing from them?
Well, Steve put seeing some Doppler velocities near 100 mile per hour near Manford, but said, but being north of the boundary, the cooler air near the surface will take the edge off some, but they're evaluating.
Let's see here.
That
Did,
is
did you
very
see,
interesting.
did you see James Adelot's comment
Yeah, I did.
about Pilts shaking like he's at a disco club?
I saw that, yeah.
I missed what you said about Bella Vista. Well, we were just trying to see if we could see some lightning. And, right now, not a whole lot that's happening, which shows you this cell is weak sauce. Oh, there we go. You saw some on the right-hand side of the screen, but yeah, they do kind of spawn out of nowhere. They can for sure, like video games. Only when a storm comes in, sometimes they respawn, but most of the time they kind of die. Well, I'll tell you what. Here's what I'm going to do. I got to do a couple things around here. We finally saw some lightning. I'm going to shut this live stream down because this storm looks pretty weak in southwest Missouri. And it's going to be a while before these storms move in. Gravit's got some good lightning. Guess what? Gravit's down. Our camera is not working at Gravit again. But we'll try to get that up and running. However, check this out. Harbor High School. Look at that camera. We upgraded that today. So if you live in the Springdale area near Harbor Meadows, Springdale 412, beautiful camera with a great view now. And that's brand new. So we updated that, and that looks really nice. And we're going to be upgrading Mount Magazine too. Cannot wait for that. There's a look at Cooper Elementary. I just saw some lightning. Better not come back with a tornado tie.
Yeah, I saw that comment just now.
We'll see. We'll see what happens. All right. Yeah, so let me tell you this here. Let's go back to Mega Doppler. I want to bring up the Mega Doppler polygons with Cam. So we are looking at a base severe thunderstorm warning, southwest Missouri. That's going another 25 minutes or so. That's pretty weak. That cell's moving towards Goodman, Anderson, Pineville, Neosho, but it's not super strong. Doesn't have any rotation associated with it. Maybe on the north end of the line. We'll watch that. That's going to be in Newton County, southwest Missouri. This line, though, is a little more intense. And there is a descending reflectivity core here. So if there would be tornado potential, as far as spin-ups are concerned, it would be right here, just to the west of Skytook, southwest of Avant, and east of Hominy. Those are going to be areas where you got to watch, and there's that circulation showing up, and I think that's honestly legit right there. So something to watch, see if there's a reflectivity nub or a surge of any kind, and that's way west of us. So we timed this out, we tracked it, and it's going to be a little while before it gets here, just to let you know. There's a new severe thunderstorm warning that just got issued. We'll show you that. But there's a look at the latest timing. Put it out a little bit out ahead of the storm. So Fayetteville 225. So about another hour, hour and a half. So here's what we'll do. One last photograph as we look at this. And that's not a bad one right there.
Critical angle. Looking pretty good.
I'll bring it up again. So there you go. Critical angle is nearly 90 degrees. It's a little over that. And the depth, do we have the depth of the shear vector anymore? Doesn't look like it. So I don't see the depth of the shear vector, Denton, because that's important. And the magnitude, the depth and the magnitude. We got everything else, but we don't have the depth of the magnitude. Gotcha. Okay, saying we'll work on it. Got it. All right. So, anyways, all righty, everyone. Well, I'm going to shut this down. Blaze, I know you are as well, and you'll be watching it. I'll be watching it. But as of now, it's going to be probably until about 2 a.m. before these storms roll in. Can you go to bed? Sure. Will you be woken up? Probably. Will I be here? Yes. Michelle is a great question. What does a critical angle mean? Well, you think should I show that graphic? If you
I
want to
say,
get into
I,
really
I,
get into the weeds, what do you
I
think?
say go for it, real quick.
Go for it. All right, we got let's see, 1,300 people on here watching the stream, so let's go for it. Let's do it. Let's just do perfect streamwise vorticity to start off. So this is why the critical angle is important. Stand by.
You could show that presentation too.
Yeah, I'm not going to do that because that's a little involved. But I will do this though. This is a cool graphic on the critical angle. So first of all, you're going to see a photograph that's on there, and you're going to see this 0 to 1 kilometer. Really, it's below that, but just in this case, we're looking at 0 to 1 kilometer. So if the surface wind is weaker than the wind aloft, that's causing a rotation, and this is called a horizontal vortex tube or a horizontal vortice. So if we look at this in like a flat plane, you can see the way that that horizontal vortex tube will be rotating because the wind is faster above the surface wind, which creates that horizontal vortex. So now the critical angle, what that tells you is that the storm is going to move parallel to that vortex line. So as that storm comes in and the updraft starts taking over, that updraft is essentially with the forward flank of the storm is going to pull that vorticity, that streamwise vorticity, which already has a counterclockwise spin, up into the vertical. Now, as that storm starts to grow, just like a figure skater, when it gets tighter and smaller, it starts spinning faster. And as it starts spinning faster, that rotation gets stronger, which can eventually lead to a tornado. And tornadoes, typically, when they spin faster, they'll come from the bottom of the cloud down to the ground. But there are, in cases of tornado genesis, where you actually get the tornado to develop at the surface and then go up. That can happen when you get some really rapid tornado development. So there you go. That is what the critical angle is telling us, is that that low level wind shear is moving parallel to the storm motion, and the storm motion is important because that pulls that streamwise vorticity up into the vertical. What do you think, Blaze? Does that make sense?
Yeah, that was really good. And Dan's done tons of research, and he's got a presentation where many times that critical angle has been right on.
And I don't think that the critical angle is done right because it's not always at 500 meters. Sometimes it's a little bit below that. And you can't just look at the critical angle at 500 meters every time. So that doesn't help. I want to show you something pretty cool. And this is there's a guy by the name of Lee Orff. And what Lee Orff does is he does a lot of modeling. And some really cool 10 let's see if I can get here and show you here. Yeah, that's really cool. but I'm trying to look for. Here we go. Okay, here we go. This is it right here. So stand by. We're really getting into the weeds, but graphic really helps. Cool. I love that. Yeah, appreciate that. All right, let's go back to. I got to show you this. So we got to share screen. We're gonna share this. Okay, hold on. I'm gonna make this bigger. Here we go. Lee Orf Supercell. We are gonna add video on this and audio. All right. Can you see that? Yes. So this is what you were seeing was that horizontal vortex tube that's being pulled up into the vertical. And this is a modeling of a
called moving from the forward flank to the rear flank. And this parade kind of keeps going for a while. And it isn't until the leading member of this parade sort of stops and things just kind of pile up in one spot that you start to see the tornado form. The tornado seems to form as an accumulation of vorticity. And subsequently or concurrently, we have this thing we call the streamwise vorticity current going on in the forward flank. And you also see vortices moving along that boundary as well. So to try to sort of strip away some of the complexity here, I've done some work. This is also more turbulent.
Another example.
Okay, so when I get a little nervous when I look at my 30-meter data and I get the impression the SVC might be this nice laminar thing. Well, it may be more turbulent in reality. So this is the new
brilliant, and there's a lot of cool stuff on that. But that is the streamwise vorticity current that you were seeing on my graphic, which looked like child's play compared to what that was. But still some really cool stuff. And so that shows that. Why am I looking at that? Well, because we want to figure out if there's tornado potential. As of now, this is not holding together for tornado potential, but still possible along the leading edge of the line. So we're going to have to watch that, especially where that line runs northwest and southeast. But this bow echo, if it comes through, yeah, this is going to pack a punch in northwest Arkansas. So one last time to show you, this line will be moving in probably around 2 o'clock in the morning. It's speeding up here. Let's see. Let's look at the latest motion. Whoa. Moving east at 60. Okay. All right. Well, it's moving a little faster. So we got to speed this up a little bit.
Because it was moving, what, about 40 miles per hour?
It says 60 now.
Wow.
That's what it says on the latest warning. So we'll take the Weather Service word for it. We'll draw a bow echo out on the leading edge of this at 60 miles per hour. And let's take this over the next 2 hours to the east. And there you go. Moving a little quicker now. So coming in a little before 2 a.m. 141. So about an hour and a half from now, it will be knocking on the I-49 corridor. Stillwell in our weather coverage area at about 1:30. So we're about an hour and a half from this line coming through. And therefore, I will launch another live stream. I do agree that we need some more heavy metal references. Yeah. I do agree with that. The ground is wet, man. The ground is saturated. Let's see here. Man, I'm trying to think. Kill switch engage. We got. I believe this line is going to hopefully weaken as it comes in. Zach's got me on that. All right. Hopefully we don't have a symphony of destruction as this storm system moves in, but we'll see what it packs when it moves through Tulsa. All right, Blaze, we're going to shut it down. We'll be watching it. We'll keep you updated, and as it starts to move in, we'll do another live stream, and then things will start getting a little more interesting as that storm system comes in. So take care, guys. I'm going to reboot this computer, too, because I know it's kind of glitchy and a little bit stalled out. So later, guys. Have a good one. See ya.